Here we've got the function y equals 12 over x squared plus 1, and we have this rectangle inscribed in the function. We want to figure out what is the largest area we can make with that rectangle. Okay, what I want to do first is point out that the sides of this rectangle are x, because that's the horizontal distance over till we get to this point x, and the vertical distance is y. So we have x times y. The area of this rectangle is x times y. Unfortunately, there are two variables here, and I don't want to do calculus with two variables. I want to try and bring that down to one variable. Well, how do I do that? I have the idea that y equals 12 over x squared plus 1. I'm going to take the function and substitute it in for y. That's going to give me x times 12 over x squared plus 1, or I can move the x into the numerator to give me 12x over x squared plus 1. So now my area function is all in terms of one variable. This is great because I can take the derivative, set it equal to 0 to find all my critical points. Okay, the derivative unfortunately requires quotient rule. I know we all hate quotient rule, but we're going to have to use it here. So the derivative is low d high minus high d low, all divided by low squared. I don't really care too much about the denominator. After all, I'm setting this equal to 0 and trying to solve, so I only really care about the numerator. The denominator isn't ever going to be 0, nor do I want it to be 0 to try to make that equal to 0. So I'm just going to look at the numerator. Distributing the 12 is going to give me 12x squared plus 12. 12x squared times, or 12x times 2x is going to be 20, or rather minus, this is a minus here, 24x squared. All right, 12x squared plus 12 minus 24x squared equals 0. This is going to be negative 12x squared plus 12 equals 0. I can subtract the 12, divide by negative 12, give me x squared equals 1 for an answer of either x equals 1 or x equals negative 1. Now, I don't really care too much about this negative 1 because, after all, we seem to be in the first quadrant. So it doesn't really matter that we have an x value of negative 1. I'm going to throw that away. We're going to use the x value of x equals 1. And now that I have x equals 1, I'm going to plug that back into my area formula, which was this guy back here. If I take x equals 1 and plug it into this function, I get 12 times 1 over 1 squared plus 1, which would be 12 over 2, which is 6.